Good morning, class. Here's a final exam review covering from 1.6 to 5.4. Here's the pledge. Before starting the exam, please read the following pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam for that matter. Unauthorized unauthorized actions include but are not limited to the use of notes, text, graphing calculators, search engines, PowerPoints, AI, and anything else. So this is the synopsis of various differentiation formulas we should be familiar with. Hopefully, we are very comfortable with. Okay. Logarithmic properties we should be comfortable with. Integration formulas we should be comfortable with. And now I want to remind you of what we have done. This is going to go pretty fast. Everything that you see, you've seen before. So to differentiate this, because the numerator just has the number, we're going to bring this up and make it to the power of -1/2. Now we're going to use the extended power rule starting with number 4. Then -1/2, we're going to use the derivative of g of x to the power of n on that. N g of x to the power of n minus 1 g prime of x. So -1/2. The parenthesis to the power of -1/2 minus 1, the derivative of the inside, 2x. Now, the product of these two is -2, with this one is -4x, and this one to the power of -3/2. We take it down, make it 3/2, positive, and the square root. So the final answer, -4x over the square root of x squared plus 3 quantity cubed. Y equals 2x plus 3 over x minus 8 to the power of 5. We'll use the extended power rule. And the quotient rule is a combination of the two. So extended power or the chain rule, we start with number 5. Same thing to the power of 4. And now we need the quotient rule by calling this f over g and using the quotient rule, f prime g minus g prime f over g squared. So 2 times the gx minus 8. G prime is 1 times f, which is 2x plus 3 over the bottom squared. We're done with calculus. We are going to distribute. We get 2x minus 16 minus 2x minus 3. 2x and minus 2x cancel each other. -16 and -3, they add up to -19. So this is the second fraction. This one, I want to rewrite this as 2x plus 3 to the power of 4, x minus 8 to the power of 4. So becomes clear the 4, the x, the power pertains to both the numerator as well as the denominator. So we have a fraction bar. What's at top? This one, and this one. The product of these two is -95, 2x plus 3 to the power of 4. The product of these two is x minus 8 to the power of 4 plus 2. You add up the exponents. The final answer is -95 times 2x plus 3 to the power of 4 over x minus 8 to the power of 6. That is the final answer. We want to differentiate this implicitly. We notice is the product of 4x squared and y. Therefore, we're going to put a raised dot in between. And we are going to use the product on that. So having said that, this is going to give us 8x times y. Y is going to give us y prime times 4x squared. So f prime g plus g prime f. 2y squared uses the extended power rule. 2 times 2, 4, y prime, and any number including e results in 0. We see that these two involve y prime, so we put them together. That means we are taking the y prime out as well as number 4. So this gives us x squared plus y. This is 8xy, moves, becomes negative. Divide both, we want to get to y prime. Divide both sides by 4 times x squared plus y. And -8 and 4, they cancel each other. They result in -2 in the numerator. The final answer, y prime, is -2xy over x squared plus y. We want to differentiate y equals cosine 3t to the power of 4. First, I want to remind you that the derivative of cosine is negative sine, and the derivative of cosine of g of x is negative sine g of x, g prime of x. The way I approach it is that it makes it easier for me if I just read cosine and pause, because I know the derivative is negative sine. However, a trigonometric function is meaningless if it doesn't have an argument. So I must use the same argument. And now the chain rule tells me I need the derivative of the argument, which is 12t cubed. I put it in front. Y prime is negative 12t cubed, sine of 3t to the power of 4 as the final answer. So now we are done. It's very straightforward. We're going to move on, and we are going to look at a related rate problem. A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at the rate of 3.5 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So here's a circular shape. From the center to the circle, the distance is called the radius. If you go both ways, is the diameter. The relationship is as follows. These two are C circumference. Circumference is 2 pi r, and the area is pi r squared. For this question, we need the area. Let's write the given. So A equals pi r squared comes from geometry algebra. We should know it. The radius is increasing, so dr dt equals 3/2 feet per second. What do we want? The rate at which the area is changing, dA dt. At what point? R equals 4 feet. So we write that. Now, we are going to differentiate this with respect to time. A equals pi r squared. We want dA dt. First, we start with its coefficient pi or multiplier, and it doesn't do anything. It just remains. We're going to differentiate r squared, which is 2r dr dt. 2 pi r dr dt. Replace the r with 4, dr dt with 3/2. We get 12 pi. Units of area, square feet over units of time, second. You always write the exact answer in your notes. If they ask for a decimal, then you go with the specific decimal that they ask you. They may not. Okay. So that's important to know. They may not ask for that. You don't have to. All right. We are interested in finding dy dt. So right away, we recognize this, that t is the independent variable. And that's important to understand. So if I want to differentiate this, the derivative of y is dy dt, the derivative of x is dx dt. So to differentiate this, I'm going to go with the extended power rule. I'm going to start with number 4, then the same thing to the power of 3. Now the derivative of the inside is 5 dx dt plus dy dt. 5 dx dt plus dy. Minus dx dt, and this is a number, 0. Just plug in, that works out just as good. 5 times 2 is 10, minus 9 is 1, and cubed is 1, so it has no bearing. 15. Distribute the 4. 60 and negative 3 is positive 57. Move it, make it negative. Divide, and dy dt is minus 57 over 4. So that's pretty straightforward, everybody. A 20-foot ladder leans against a building. The base of the ladder slips over at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You have to have it drawn. So here's the building or the wall. Here's the ground, and it's slipping away this way. Here's your ladder. So as things happen, we have to define our variables. We're going to define the base as x, the height as y. The ladder has the length of 20 feet. You can say L or C or nothing, just 20 feet. That's fine. So as it moves this way, it creates the speed of dx dt equals 2 feet per minute, right? Slips away. Then it comes down and it creates the speed of dy dt, and that's missing, we are looking for. So we are going to write dx dt is that, dy dt is missing. At what point? When the base is 12 feet. What is the base? X. So you must have a drawing. You must define your variables. Now, according to Pythagorean theorem, a squared plus b squared equals c squared, because this is a right triangle. So x squared plus y squared equals 20 squared. This, if we differentiate implicitly, gives us 2x dx dt to y dy dt 0, because 20 squared is 400 and is a number. Any number results in 0. So without this, we can't get this. So we have to write that. Now I want to plug in, and I notice I have everything except what is the value of y when x is 12? So I have to evaluate it from the Pythagorean theorem. I plug in. This is 12 squared, which is 144. This is y squared. This is 20 squared, which is 400. I subtract 144, and I get 256, and that gives me 60. Now I've got everything. I'm going to plug in. 2 times 12 times 2 is 48. 2 times 16 is 32. I'm going to move the 48. I'm going to divide by 32, and I get negative 3/2 feet per minute. Notice x is increasing, dx dt is positive, y is decreasing, dy dt must be negative. And it means the height of the ladder is decreasing at the rate of 3/2 feet per minute. That's the meaning of it. All right. How do we find limits? We plug in. If it gives us a number, we're done. If it gives us 0 where a number is 0, we are assuming, of course, when I say 0 where a number, the bottom is something other than 0. If it's a number over 0, we have to figure out it's infinity or negative infinity. And here's the reason. Any number, the left and right, has the same sign except 0. 0 on the left side is negative, on the right side is positive, so it could create a positive or negative infinity. However, an indeterminate form is 0 over 0, infinity over infinity, infinity minus infinity, and there are other forms. That's what we come across mostly in calculus. So for example, right here, if I plug in, I get infinity over infinity, which is an indeterminate form. Now, there are two ways to deal with that. First, because x is approaching infinity, the technique is to divide by highest degree term in the denominator. So if I divide everything by x squared, this becomes 2, this becomes 1. This becomes 8 over x. This becomes minus 16 over x squared. As x approaches infinity, this goes to 0, this goes to 0, so the answer is 2. However, a general case for any fractional form is to put it in its lowest term by factoring. Obviously, the denominator is a squared minus b squared x plus 4x minus 4. Obviously, the top, I can take the 2x out. And therefore, I can drop the common factor, and I get 2x over x minus 4. If I work on that instead, I have to divide by x. Again, why? Because x is approaching infinity. If x is approaching infinity or negative infinity, that's the technique. So when I divide by x, this becomes 2, this becomes 1, this becomes negative 4 over x. This goes to 0 when x approaching infinity, 2 over 1. We are done. This one, if I plug in, I get 0 over 0. The technique is always factoring. If we can, we already have the factored form. So we're going to use the factored form. Now, if I plug in negative 4, 2 times negative 4 is negative 8. Minus 4 is also negative 8. The answer is 1. And I'm done. So factoring is the key, which will do the job. What about here? When x approaches 0, if I don't do the factoring, I hope you see that you do get 0 over minus 16, which is 0. So that works out. If I go with the factored format, again, I get 0 over minus 4. The denominator is different, but the result is absolutely the same. What if we look at the same, but this time as x approaches 4 from the left? In this case, and in this case, 4 from the right. I hope you see if you plug in and you can work it out, each one becomes 0 over 0. So what's the technique? Again, let's look at the factored form in this case, and in that case, doesn't matter. Now, I hope you see if you plug in 4, the numerator becomes 8, the denominator becomes 0. Now, please understand what's the difference between the two when x approaches 4 from the left or right. From the left or right, the top is close to 8. From the left, it's like 7.9999. From the right, like 8.0001. So the top is 8. The bottom is 0 in both cases, but it now makes a difference because remember, if you're dividing by negative or positive, it changes the sign. So you need to know which one. And four from the left, you can even use 3, but I'm going to go for 3.9 minus 4 is negative 0.1. And I just want the sign. This tells me the answer is negative infinity. On the other hand, here, 4 from the right, I can even use 5 because I just want the sign. But 4.1 minus 4 is positive 0.1. So 8 over 0 from the right, and it's positive infinity. So that's important for everybody to see what's going on. Okay? So I hope everybody is fine with that. So we can move on. All right. What happens here? Again, we are going to plug in. So if you plug in e to the power of minus t, what happens to that? Reminding you, a to the power of minus m is 1 over a to the power of m. E to the power of minus t is 1 over e to the power of t. T is approaching infinity. We have 1 over e to the power of infinity, which is 1 over infinity, which is 0. And therefore, the answer is 12 over 4, which is 3. What about this one? If t is approaching infinity, so does e to the power of t. And infinity times a number, positive number is still infinity. And so the answer is 0. Part C becomes identical to part A because in this case, it's e to the power minus t and t is approaching infinity, so it gives us e to the power minus infinity. Okay. And in this case, gives us exactly the same thing because t is approaching minus infinity, and the answer is the same. And this last case, just replace the t with 0, and e to the power of 0 is 1, so 12 over 4 plus 3, or 12 over 7. What about differentiating this? We are going to bring the denominator up, raise it to the power of -1, so we don't have to use the quotient rule. So we start with number 12. So f prime of t is 12, and then the same thing to the power of, I'm going to subtract 1 minus 2. So times minus 1, first times the exponent. And then the same thing to the power of minus 2. Then the chain rule, the derivative of the inside is 3e to the power of t. So now we have a fraction bar. This goes down and take a positive exponent 2. 12 times -1, negative 12 times 3, negative 36 e to the power of t is in the numerator, everybody. We want to find the following limits, and if we plug in 5, we get 0 over 0. And remember, it is 0 in the denominator, which is a problem. So the technique is factoring. The numerator is a squared minus b squared, and the denominator, you just have to factor the x out. You drop the common factor of x minus 5, and if you plug in now, you get 10 over 5, which is 2. This one is also 0 over 0. You can plug in and you observe. Because it's a complex fraction, the technique is LCD, which is multiplication by 4x. And you're going to multiply the top and the bottom by 4x. So first and foremost, the denominator, you don't do anything because x is approaching -4. X plus 4 goes to 0. That's a problem. You want to get rid of it. You're hoping. So these two, the product, 4 goes away, it's x. These two, x goes away, it's 4. So x plus 4. They cancel each other. 1 over 4x. If I plug in -4, get -1 over 16, which is the final answer. Next one, also if you plug in, you get 0 over 0. The technique is the conjugate. The conjugate of the numerator is square root of 1 plus h plus 1. You put it at top and the bottom. And again, you don't do anything to the denominator because h is a problem. You're hoping to get rid of it. The numerator, according to a minus b plus b, becomes a squared, the square root of 1 plus h squared minus 1 squared. So the first one comes out. The second one is 1. 1 and minus 1 cancel each other. H cancels out the h. And now if I plug in, I get 1/2 as the final answer. What about this one? This is not a rational function. Okay, you plug in, becomes infinity over -infinity. However, because t is approaching infinity, you use the same methodology. In the case of a rational, you divide by highest degree term in the denominator, in this case by highest value, which is e to the power of t. So as you do that, these two remain. This becomes 1, this becomes -3. T is approaching infinity. This is 0, this is 0, positive 1 over -3, or -1/3 is the final answer, everybody. E to the power of 2x times ln x, we want to differentiate. So I'm going to put a raised dot. and use the product rule on that. F prime G plus G prime F. So what is F prime? E to the power of 2x itself times 2. That's F prime times G ln x. And ln x, it's 1 over x times F, which is e to the power of 2x. So if I take the e to the power of 2x out as a common factor, I'm left with 2 ln x here, 1 over x here, and I'm done. So again, pretty straightforward, everybody. What about this one? The first step is to simplify log, decompose the log if you can. It cannot be done, then we're going to move on. So first and foremost, flip it over. So 1 over f of x. Then by the chain rule, the derivative of the inside times 2x. Then you look at the base. If the base is e, you're done. Since it's not, 1 over ln b. 1 over ln 5. You rewrite it. 2x is at top, and the bottom is x squared plus 1 times ln 5. So that's pretty straightforward, everybody. Now, you can differentiate by flipping this over and using the quotient rule. There's no need because it's a lot easier if you decompose it as ln of 2x minus ln of 2x plus 1 first. And by the way, I'm using it. I'm going to do 2 steps. There is really no need. I use the quotient rule, and now I'm going to use the product rule on this one, becomes ln2 plus ln x. So now I'm going to differentiate one by one. This is a number, becomes 0. This is 1 over x. This one you flip it over. Minus 1 over 2x plus 1 times 2. And this is the only calculus step I'm done. I'm going to take a common denominator of x times 2x plus 1. Then 1 times 2x plus 1 minus 2 times x. Right. 1 doesn't change anything. These two cancel each other. We get 1 in the numerator. The final answer is f prime of x equals 1 over x times 2x plus 1. Find an equation of a tangent line for the function f of x equals x squared minus 3x minus 1 at x equals. Well, we need two things. We need a slope, so we're going to differentiate 2x minus 3. And we're going to plug in 4. So if you plug in 4, 2 times 4, 8 minus 3 becomes 5. We also need a pair x comma y. We have x. How do we find y? Plug it into the original function, f of x. So if I plug it into this, I get 4 squared, 16, minus 3 times 4, minus 12 is 4, minus 1 is 3. So I'm going to use the point slope, y minus 3 equals 5 times x minus 4 5x minus 20, move the negative 3, the final answer, y equals 5x minus 17 is the equation of a tangent line. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. Write the expression for Q sub n plus 1 in terms of Q sub n. The formula is B sub n plus 1 is R, B sub n plus C, B sub 0 or A. Well, when we deal with that, we need to know what is the constant. And because 12 hours is a time step, every 12 hours we give this much. This is the constant. What remains, the percentage, the portion that remains in the body is 40%. That's R. Okay. So we are going to write the given. Instead of a B, we're going to use Q. So we're going to say Q sub 0 or A0. That is always 0 unless otherwise mentioned. The amount of constant C is 300 and R is 40% or 0.4. So write the given. It makes it easy to move on from there. Now the first part, Q sub n plus 1, we're going to write B sub n plus 1 and change it to Q. And now all you have to do, go back to the given, replace the R with 0.4, C with 300, and you're done. Find the formula for Q sub n. We're going to write the formula for B sub n and change the B to Q. Now, again, going back to the given, replace, of course, Q sub 0 is 0, so it doesn't change anything. This is 0. Lowercase is 300 and R is 0.4. Therefore, we're going to write this is 0. This is 0.6. Put it underneath 300. Six. 3,000 over 6 is 500. How much is left after the fifth tablet? N equals 5. Replace the n with 5. Put it into a calculator, you get 494.88 milligrams. Finally, what is the limiting value? You take the limit of the expression you found in part B. You may see the answer right here, but just to be on the safe side, we're going to use the limit laws by taking the 500 out, take a limit of the first step, the second one. Obviously, this is 1. Limit of any number as n approaches anything is the number itself. This one is 0 because when you have a base to the power of n and n is approaching infinity, if the base is between -1 and 1, it goes to 0. So the answer is 500 milligrams, which means, therefore, regardless of how long the treatment continues, the drug concentration will never exceed the limiting value of 500 milligrams. And that means they have found it to be safe for the patient. What about f of x is 4 e to the power minus 0.2x minus sin x? We want to differentiate and integrate. I want to remind you the difference between the two. That's why we're going to do that. Exponential, the differentiation and integration results in the same thing. We're going to multiply by negative 0.2 minus sin x gives you minus cosine x. Multiply these two, the final answer is negative 0.8 e to the power minus 0.2x minus cosine x. If you integrate, you have to write this with a dx next to it. This one, again, the same thing, but this time we're going to divide by negative 0.2 minus the derivative of sin x was cosine, but the integral is negative. Negative and negative gives you positive cosine x and a constant, or you can use that. 4 divided by negative 0.2 is 40 divided by negative 2. So the final answer, f of x, is negative 20 e to the power minus 0.2x plus cosine x plus. What if we make it into an initial value problem by giving it a pair, f of 0 equals 20, that means x is 0, and f of x or y is 20, plug in. This is 1, this is 1, so minus 20 and 1, we have minus 19 plus what number is 20, c is 39, plug in. And this was a general solution. Now this is a particular solution. This is a family of functions because of C has infinitely many solutions. This one has only one solution. We've done this integration a couple of times already. So first, let's do a couple of algebraic steps. Change this to x to the power of 1/2, then divide. And now make it ready for the power. 1 over 1/2 plus 1x to the power of 1/2 plus 1. 1 over negative 1/2 plus 1x to the power of negative 1/2 plus 1. And because we are done, we add a constant. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. The reciprocal of this is 2/3. The reciprocal of this is 2. You could rewrite this as square root of x, and this one x squared of x. So 2/3 x squared of x plus 2 squared of x plus a constant. We are done. We're going to get to substitution, and the tip is look for this function u equals g of x anywhere in the integrand and its derivative du, or g prime of x multiplied by dx. When we are dealing with polynomials, the more complicated one, in this case x squared plus 5, is a choice of you. You have to write what is u before you get to du. So the derivative is 2x, du dx is 2x, and du is 2x dx. I've seen students just writing that without the u. I have no idea how you get there, but you have to put that down. So we're going to rewrite this so it becomes clear this is u. Moving 2x next to dx, that's du. So u to the power of 30 du. Now the integral of that requires the easy way of power rule, 1 over 31 u to the power of 31 plus c. Reverse substitution gives us the final answer, 1 over 31 x squared plus 5 to the power of 31 plus a constant. What about a fractional form? The first step is simplification, putting it in lowest term. We can't in this case. Denominator is a choice of u. Notice that derivative of this is the numerator. So du is e to the power of t dt. We are going to rewrite this so it becomes clear to the reader. This is du over u. As you know, that's a natural log. So ln of absolute value of u plus a constant. Bear in mind, you need an absolute value sign. However, when we replace it, if you know the statement 5 plus e to the power of t is positive, which is the case, you can lose the absolute. Rational, first thing first, can I simplify it? Well, I'm reminding you of the quadratic formula is ax squared plus bx plus c equal to 0, which results in x being minus b plus 1 is a squared of b squared minus 4ac over 2a. B squared minus 4ac is important. It's called the discriminant because it gives you a lot of information. If it's positive, you have two distinct real solutions. If it's 0, you have one real solution, becomes irrational. And if it's less than 0, you have no real solutions. You have two complex solutions, a plus minus bi. Furthermore, if it's a perfect square number, this can be factored. And I've shown you that when we look at this one, a is 1, b is 2, c is -1. So b squared is 2 squared minus 4 times a times c is 4 and 4, 8. Not a perfect square, can't be factored out. You're going to move on. The denominator is a choice of u. The derivative is 2x plus 2, or 2 times x plus 1. Du is the same thing times dx. We're going to rewrite such that dx belongs to the numerator. Everything is in order, but 2 is missing because 2 is a number. I'm going to put the 2 and its reciprocal. Remember, you can solve for dx. This is much faster. This is identical to that. So this part gives you a natural log, a reverse substitution, and keeping the absolute value because this expression can be positive or negative. If you have the reciprocal of this one, you have to do division, long division, or in this case, you can do synthetic division. If you have the reciprocal of that, you just make up two fractions because the denominator has only one algebraic expression. You can see that this is 5 e to the power minus t, this is plus 1. And this one, the answer is itself, divide by -1, or makes no difference if you said negative times, but this is t and a constant. And now we are done.